Hello everyone, we're back to another business statistics tutorial. In today's video, we'll be introducing a brand new topic, the hypothesis testing, which we learned from our last week's lecture. Hypothesis testing is one of the most important concepts in statistics because it allows us to use sample data to evaluate claims about an entire population. Although the process may seem complicated at first, you will find that every hypothesis test follows the same basic structure. In today's tutorial, we'll focus on four main objectives. First, we'll learn the differences between the null hypothesis and the alternative hypothesis. Second, we'll discuss how to determine whether a problem requires a left tail, right tail, or two-tail test. Third, we'll learn about how to interpret p-values and use them to make statistical decisions. Finally, we'll apply the complete hypothesis testing process to both proportions and population means. So let's get started. Let's begin by answering a simple question. What exactly is hypothesis testing? In everyday life, the business often make claims. For example, a company might claim that 95% of customers are satisfied with their service, or that their delivery time is less than 2 days. The problem is that it's usually impossible to ask every customer or measure every delivery. Instead, we collect a sample and use the information to decide whether there's enough evidence to support or reject the claim. That's exactly what hypothesis testing does. It uses sample data to evaluate a statement about the entire population. One important idea to remember is that we always begin by assuming that the null hypothesis or H0 is true. Our job is not to prove H0 is correct. Instead, we ask whether the sample provides enough evidence to reject it. At the end of every hypothesis test, there are only two possible decisions. Either we reject the null hypothesis or we fail to reject the null hypothesis. Notice that we never say the word we accept the null hypothesis. We'll come back to that idea later in the chapter. Hypothesis testing is widely used in business, marketing, manufacturing, healthcare, and many other fields whenever decisions need to be made using data. Now that we understand what hypothesis testing is, let's look at two most important components of every hypothesis test: the null hypothesis, or H0, or the alternative hypothesis, or H1. Many students found this part confusing at first, but once you understand the roles of these two hypotheses, the rest of chapters becomes much easier. Let's start with the null hypothesis. The null hypothesis represents the current belief or the status quo. It's the statement that we assume is true before looking at the sample data. One simple rule is that I always recommend remember the null hypothesis always contain an equal sign. In other words, H0 always include equals, less than or equal to, or greater than or equal to. That's because H0 represents a specific claim about the population. Now let's look at the alternative hypothesis. The alternative hypothesis is the statement we're actually trying to find evidence for. Unlike the null hypothesis, H1 never contains an equal sign. Instead, it uses one of the three symbols: greater than, less than, or not equal to. One of the easiest ways to lose marks on a hypothesis testing question is choosing the round tail. The good news is that this decision is actually very straightforward if you pay attention to the wording of the question. Instead of looking at the numbers first, start by reading the claim carefully. Certain keywords immediately tell you which type of test to use. If the claim says greater than, you'll use a right-tailed test. Think about it visually. If we're looking for values that's greater than expected, The unusual observations will appear on the right side of the distribution. If the claim says less than, then you use a left-tailed test. In this case, we're looking for values that are much smaller than expected, so the critical region moves to the left side of the distribution. Finally, if the claim says different, change, or not equal to, you will use a two-tailed test. A two-tailed test checks for evidence in both directions. We're interested in values that are either much larger or much smaller than expected. Here's a simple trick that many students found helpful. Before writing any formulas, circle the keyword in the question. If you see greater than, think right. If you see less than, think left. If you see different or not equal, think two tails. Making this decision first makes the rest of the hypothesis much easier because you know exactly what p-value or critical region you're looking for. Remember, the direction of the rest always comes from the alternative hypothesis, not the non-hypothesis. There's another small detail that's easy to forget but very important on exams. Now that we know how to choose the correct tail, let's move to one of the most important ideas in hypothesis testing, the p-value. Let's talk about the most important concept, the p-value. Many students can calculate a p-value using Excel or a calculator, but they are not always sure what it actually means. So instead of starting with a definition, let's begin with an example. Imagine a company claims that 95% of its products meet quality standards. We collect a random sample and perform a hypothesis test. After doing the calculation, we obtain a p-value of 0.02. Now the question is, what does the number actually tell us? A p-value tells us how likely it is to observe our sample result, or something even more extreme if the non-hypothesis is actually true. Notice that the last part is very important. The p-value is calculated under the assumption that the non-hypothesis is true. So we're asking if the company's claim is actually correct. How surprising are our sample results? If the bad probability is very small, then our sample would be considered unusual and we begin to doubt the non-hypothesis. This leads us to the decision rule. We always compare the p-value with the significance level, which is represented by the Greek letter alpha. In most business statistics courses, alpha is 0.05 unless the question tells you otherwise. The decision rule is actually very simple. If the p-value is less or equal to alpha, we rejected the non-hypothesis. If the p-value is greater than alpha, we fail to reject the non-hypothesis. Many students try to memorize these rules separately, but I recommend thinking about logic instead. A small p-value means that our sample would be very unlikely if the non-hypothesis were true. Since the result is so unusual, we have evidence against the non-hypothesis. On the other hand, a large p-value means our sample is quite consistent with the non-hypothesis. This is simply not enough evidence to reject it. So we knew how to make decisions in hypothesis testing. Let's talk about something that's often overlooked. What happens if our decision is wrong? Whenever we perform a hypothesis test, there's always a possibility of making a mistake. In statistics, there are two types of errors known as type 1 error and type 2 error. Let's start with type 1. A type 1 error occurs when we rejected the non-hypothesis even though it's actually true. In other words, we conclude that there's evidence for change, when in reality nothing has changed. For example, imagine a company claims that its products meet quality standards. If we incorrectly conclude that the products does not meet those standards, even though they actually do, there would be a type 1 error. The probability of making a type 1 error is presented by alpha, which is also the significance level that we choose before conducting a test. This is one reason why choosing alpha is very important. Now let's look at the type 2 error. A type 2 error happens when we fail to reject a null hypothesis even though it's actually false. In this situation, there really is a difference or a problem, but our sample doesn't provide enough evidence to detect it. For example, suppose a new manufacturing process actually reduces defects, but after collecting sample data, we conclude that there's no improvement. We missed a real effect. That would be a type 2 error. The probability of making a type 2 error is presented by Greek letter beta. You may also see the term power. The power of a hypothesis test is simply the probability of correctly rejecting a false null hypothesis. In other words, it's the test's ability to detect a real differences when one actually exists. A higher power generally means a better hypothesis test. One of the easiest ways to increase the power of a test is to increase the sample size. Larger samples always provide more reliable information and make it easier to detect meaningful differences. Now let's apply everything we've learned to our first complete hypothesis test, which is testing a claim about a population proportion. A population proportion is simply a percentage or probability. Whenever the question talks about things like the percentage of satisfied customers, the proportion of defective products, or the percentage of voters supporting a candidate, you are most likely dealing with a population proportion. Before performing the test, there are few requirements that we need to check. First, we should have a random sample. This helps ensures the sample represents the population fairly. Second, because we are using a normal approximation, the values of NP and NQ should both be at least 5. Remember that P is the proportion stated in the null hypothesis, not the sample proportion that you calculate from the data. Many students accidentally use the sample proportion when checking these conditions, so pay close attention to which value you are using. Once the assumptions are satisfied, the hypothesis test follows the same process every time. First, write the null hypothesis and the alternative hypothesis. This is always starting point because it tells us what we are trying to test. Next, calculate the test statistic, which tells us how far our example proportion is from the claimed population proportion. After that, find the p-value using your calculator, Excel, or statistical software. Finally, compare the p-value with significance level. Make your decision and write a conclusion in words. Notice that the conclusion should always answer the original question. Instead of simply writing reject H0, explain what that decision means in context. For example, you might write, there's a significant evidence to conclude that the proportion of satisfied customers is greater than 90%. That final sentence is just as important as the calculation itself. One study tip I like to share is that whenever you are solving a hypothesis testing question, don't think of it as 8 separate steps. Instead, remember this simple workflow. Write the hypothesis, calculate the test statistic, find the p-value, make a decision, explain your conclusion. Now we've learned how to test a population proportion. Let's look at another very common type of hypothesis test, testing a claim about population mean. Our final topic for today is testing a claim about a population mean. The overall process is almost identical to what I just learned for population proportion. We still write the hypothesis, calculate a test statistic, find the p-value, and make a decision. The biggest difference is deciding whether to use a t-test or a c-test. Fortunately, there's an easy rule to remember. If the population standard deviation is unknown, we use the t-test. If the population standard deviation is no, we'll use the C-test. In practice, population standard deviation are rarely known, so you'll probably find yourself using the t-test most frequently. Another important concept is degree of the freedom, often written as df. For one sample t-test, the degree of freedom is just simply the sample size minus 1. For example, if your sample contains 25 observations, then your degree of freedom would be 24. You'll need this value whenever you use a t-distribution table or a statistical software. Before performing a t-test, make sure the assumptions are satisfied. The sample should be randomly selected. In addition, either the population should be approximately normal distributed, or the sample size should be reasonably large. Once those assumptions are met, the rest of hypothesis tests follow exactly the same workflow we already discussed. You still need to write the hypothesis correctly, identify the tail of test, calculate the p-value, compare it with alpha, and most importantly, write a meaningful conclusion. In other words, the process doesn't change. The only thing that changes is the formula you use to calculate the test statistic. So to summarize, for a proportion, you'll use the hypothesis test for a population proportion. For a mean, you first decided whether to use a t-test or a c-test based on whether the population standard deviation is known. Now we've reviewed the entire hypothesis testing process, from writing hypotheses to make decisions. You should have a clear framework for approaching these questions. Let's finish today's tutorial by summarizing the key ideas that I'd like you to remember as you continue practicing this chapter. Before we wrap up today's tutorial, I'd like to share a few things. Starting this week, I'll be creating and posting a weekly tutorial review video to help you review the material covered in the last week. Each video will summarize the key concepts, explain important formulas, and work through some meaningful practice examples. To access the video, simply open the PowerPoint I posted on Slate and click the hyperlink on the first slide. It will take you directly to the weekly tutorial video. On Tuesday, tutorial from 1 to 2 p.m. Will mainly be a question and answer session. Instead of spending the entire tutorial reviewing the weekly concepts again, we'll use this time to answer questions, work through challenging problems, and clarify any concepts you find difficult. I wish you all the best for the rest of the semester. Keep practicing, stay curious, and remember that the statistics becomes much easier once you're understanding the reasoning behind formulas. Thank you for watching. My name is Lucienne Zhang, and I will see you again in the next tutorial video. Take care.